I guess like Anil sir already talked about like who I am. Are you able to see my screen? Hello.
Yes, yes, yes.
Yes, sir. Yes, sir. Yes, sir.
Okay, cool. So this is since this is like a webinar, uh, I'm gonna like try to keep the interaction minimal because it's really hard to like interact over the chat or in like it's just much harder than in person. And sir already introduced about me. So I was there in 2006, just like you folks. I joined in Jodhi Engineering College, and since then I was there for like 4 years, and then I joined TCS, Tata Consultancy Services. I was working there for briefly for mainframe computers, and then later Java technology, and then I moved to United States in 2014 um, for doing my master's. Uh, I was interning with Amazon during my master's, and then I joined back after my college. And it's been like close to 4 years working for Alexa, specifically on the connected devices, IoT, cloud side of things. So, um, so I'm gonna talk about like basically like what's like a daily responsibility or like a general responsibilities of a backend engineer. But before that, I like to give you a different perspective of things. Like many times, like we often like get focused too much into the nuances, and we forget like why we are doing all this. So before getting into the software development and the engineering field, like let's think about that, right? Like so we are all life forms, and humans are one of the most advanced species. But then engineering kind of started even before humans. So to explain that, like look at the qualities of engineering. Like if you Google this, like you'll get these qualities: curious by nature. Engineers are curious. They always try to explore different areas or different problems. They explore those problems, and then they formulate them into a technical terms, and then they try to solve them. So they should be like proficient in STEM skills. This is not like specific for software development engineers. It's common for everyone. Communication skill. So they are interacting with others and figuring out what the problem exactly is. Whether it's a civil, mechanical, all engineering fields, all engineers, they are doing the kind of the same in this context. They are team players. It's hard for a single individual to contribute too much. Even Einstein or Isaac Newton or those big names, Bill Gates, or all of them, including us, we all are part of those that human species where we are all like social animals, right? We have social skills, and we talk to others about our problems, and we try to get help from them, and then we collaborate to solve bigger problems. So team playing skills are like a must in this field. Improvisation is another one. We might be like uh, we might like find a solution, we might deploy it, and after a while we will figure out like there is some nuances, there is some improvements that we can do, and like a good engineer will be always looking for how to make their systems better. So based on those qualities, look at let's look at the nature, right? Keep apart humans for 1 minute. Look at these animals, these life forms. So many of you already would have seen like in Animal Planet or National Geography on like how many of these animals solve problems. They are very good at solving problems. And whenever we talk about like the engineers from nature, we talk about beavers or birds that actually create a beautiful nests and whatnot. So I pick this list based on the qualities of an engineer. So crows and ravens are known to be problem solvers. They even sometimes like make their own utensils to have food. Rats, they explore new areas and try to figure out like new areas in maze just out of curiosity. The sharks and the killer whales, so the top right and the top bottom, Those animals are capable of like teaching or working with others and learning skill from elders. So that sharks that jumping out of that ocean, like catching a seal, you can see that only in South African coast. And the reason for that is like they learn from other great white sharks. And if at all, like for some reason, all those sharks perish, none of the new sharks will actually be able to learn that technique. Same goes for killer whale pods. Each killer whale pods have improvised their hunting techniques over the course of time. Certain pods in Australia is capable of killing rays in a specific manner. They figured out that there is a weakness in great whites, and if you flip them around, they go to a catatonic state. Hyenas, they are great team players. They solve problems with that team spirit mentality. The one in middle is an interesting one. It's not very popular. It's called Clark's Nutcrackers. So there's this interesting problem in computer science. It's called traveling salesman problem. Some of you might have already learned about it. Some of you already know about it. That particular problem is about like visiting different places with the least distance possible. So if you are going to A, B, C, and D, you want to like figure out like which sequence is the shortest. And these little guys, they store their pine nuts in hundreds and thousands of locations, and they can figure out like what's the shortest path or shortest possible path through all of this. Cows, they solve problems, and they sometimes have like eureka moments when they solve problems, and orangutans, So basically, like what I'm trying to say is like engineering is not like a skill that's dedicated to humans, or it's not like something specific. In some form or the other, it was there in like other life forms. Moving on. Now let's take humans then. So you might see like a day and night difference between the Stone Age era or like the ancient humans and the today's humans, right? We have like all these technologies and whatnot. But since the Stone Age, our brain hasn't changed much. I mean, it's not like it never changed, nothing changed, but it hasn't changed much. In fact, it actually shrunk over the course of time. So if you look at the Stone Age, like humans were observing in their surroundings, they were encountering problems, or they were exploring new frontiers, and they were trying to build tools or use the resources they have, or delegate tasks, or achieve efficiency or improvisation by domesticating animals and all that stuff. And same is happening on in the modern world, right? Like we have machines, we have satellites, and the problem solving skills are like in a much advanced form, but then it's kind of still the same. Explore, formulate that into a technical problem, solve that once and for all, and improvise them. Why that difference between that ancient human and like the modern world, right? One of the cases, like how we achieve that is like Isaac Newton put it like the best way possible. Like if I've seen further, it is by standing on the shoulders of giants. So it's basically saying that whatever we are trying to achieve, it's all based on what our ancestors have achieved. We are just building on top of it. And after a while, like I said, like earlier, like we are human beings and social. So whenever we have a problem, we try to interact with each other, and we try to seek help, and we employ like others' brains as well, right? So brain is our biggest power source, right? Like with respect to problem solving skills, what other animals doesn't have, or in this much advanced form. So we collaborate with each other, we talk to each other about our problems, and that becomes their problems, and then they try to solve that for us. I'm talking about like collaborative effort here. So and then humans were like, okay, so we kind of like offloaded I guess like I'm getting some notifications. Yeah. So we kind of offloaded the mechanical work to say cows and horses and other animals and other mechanical apparatuses. We improvised our hunting skills and efficiency and whatnot. That we introduced farming and everything, and then humans started like wandering. So we are like collaborating together and trying solutions. And one of the main reason for that is like brain is only for humans, and it has like this amazing problem solving skills. So can we offload that, or can we outsource some of it? And the result is machines or computers, to be exact. So we created these computers, these machines. It kind of mimics the behavior of human brains. They solve certain aspects of the limitations of human brain. Also, they enhance in certain cases, and sometimes they just mimic exactly how it is supposed to be. So mathematicians usually, like in the past, like mathematicians usually used computers, and they started formulating their problems and making it more advanced and advanced. But then there's significant difference between these two, like biological machine and synthetic man-made machine. The underneath one is working based on neurons and biology and electric signals and whatnot, while the other one is still using the same electric signals, but in a different form, like zeros and ones and silicon-based devices, backend, right? So, and on top of it, like humans have this way of like communication. So they have all these different type of languages that evolved from time to time, depending on their use cases in that geographical region and culture. And on the other hand, for computers, we kind of invented it ourselves. We wrote languages on top of the bytecode or the assembly code that we had, and which is like human readable form. So humans can actually instruct computers in a somewhat human readable form, but then still in an unambiguous way. So like programming is just that. That's a different angle, right? Like we always like there were like my friends, like there were like friends who when I was in college who were like afraid of programming languages. Oh, this is hard. I can't learn this. I have to learn it like by heart for my exams. The piece that they are missing is that they are not seeing it as a equivalent to like languages, other languages, human reading, human language skills, right? If you look at humans, like a person who is traveling to Arabia at the age of 50, he's capable of learning Arabic. Or at the age of 20, somebody's going to Mexico, he's capable of learning Spanish. And computer language skills are also like very similar. It can be acquired. It's slightly different from the usual languages, human languages. In many ways, it's a better language. That, for example, in human word like this grammar, like English and all, like multiple word means has the same meaning, or the same word has multiple meanings in the same context. In different contexts. Whereas computer languages are like hard, like unambiguous. If you write something, that's how it's going to work. There is no ambiguity there. So yeah, so those are the tiny differences. But other than that, like there are like nuances. There are like striking similarities. If you learn like one language, for example, Java, all the other object-oriented languages becomes easier for you. It's not exactly the same, but then it's kind of using the similar constructs, object-oriented principle, design patterns, and all that. And if you learn a functional language like C, almost all the other functional language becomes like easier to learn. It's similar to like how it's easier for us to learn Tamil if our mother tongue is like Malayalam. And I look at on the left side, right, the English and Spanish, like one is Blue Ocean, the other one is Oceano Azul. It's not very different. So it's easy to pick up. That's my point. So all we need to know is like one single language that's like strong enough, and that's it. Like that's all you need. Like, and everything else can be picked up on the way as needed, because there are like hundreds of languages or grammar or tools built on top of certain languages and scripts out there, and it could be like overwhelming to us when we search internet which technology we should learn or which tool we should learn. It's hard for us to learn. So to all of it, right? But we never think the same issue with related to the existence of thousands of human languages out there in the world, right? We just like learn topmostly like use like English, one or two, and then just because we happen to born in a certain place at a certain time to certain parents, we learn our mother tongue. Actually, ping me if I'm going too fast, and then you guys are like feeling like hard to catch up. Yeah. So going back to the software developer, right? In the previous slide, I mean, this bridge, like the gap between, or the difference between these two languages, the way that humans understand and the way that machines understand, that's where a software developer comes into play. Like, our job is basically to gather requirements for all the problems out there with respect to humans. It could be finance, medical field, satellite, astronomy, climate change, whatever. We talk to those folks. Mostly they are business people. It could be like a social cause. It could be like for example, like COVID. It could be for an election. It could be for entertainment. So whoever has those expertise in those areas, we reach out to them or they reach out to us, and we listen to their problems, their issues, and we try to come up with creative solutions to that. We define that problem in a technical context, or we formulate a technical problem out of it, and then we find the solution for that. We design it. We design the solution, and our trump card is machines and the ability to instruct machines to do certain things. So we translate all that solution logic into machine understandable form or understandable instructions, and then we use those machines to solve that problem for our clients. It doesn't matter like which field we are working on, whether it's finance or IoT. This is essentially what we are doing. This is essentially what our place in this world. So what are the benefits of software development compared to other jobs? So you can contribute to any field of interest. When I remember the day, like when I passed my 10th grade and I wanted to like take +1, people were asking like, do you like computer science? Do you like math? Do you like biology? And I was like, which one? I have no clue. I don't know which one to take. So I was like, which is the option that I can take and I can decide later? And the answer was that at the time was like biology and mathematics. So I took that. And same question came to me after 2 years. I like biology a lot, so I was about to go there, but then my mom kind of convinced me to, like, I'm also like technically sound, like you're interested in solving puzzles, like why don't you try this one out as well? And then when I explored more and more, I figured out that, okay, like everybody's, at the time, electronics and communication was like kind of hot field. So everybody were like preferring that over computer science. And I was like, nope, I want computer science because it does. I have no clue what I want to work on. But then even after like 4 years, when I graduate, I can decide in which field I want to work on. I can contribute to any field. I guess like it's because I which I don't know. I think it's called Badalma Digest or whatever. They had an edition on computers and the fields that the computer scientists or engineers were working on, and that's how I got that info. Maybe just luck. So the benefits: contribute to any field of interest, work anywhere. There are folks who are working from Hawaii, from a remote location because they love oceans, and they're working with teams in Seattle. Same goes for like people working from Cancun or Mauritius or Thailand, anywhere, literally anywhere in the world. It's not like everyone is like doing that, but doing that sort of thing. But whoever want to, they have the choice. And now with COVID and work from home policies and whatnot, like many companies are increasingly asking or giving the employees the choice to do that. I think Twitter did this. I think it's Twitter. Someone just recently, like a big company, like recently announced in the United States that they are not gonna enforce like everyone to be in like one location. The employees can feel free to like work from any locations they want. The other thing is like it's not boring at all. Like constant learning curve. You can take a technology and like be stagnant there for a while if the technology is still in demand. But in most cases, you have to like learn new technologies and like move forward because this is like a fast-paced, highly evolving platform or a field. So you have to like constantly learn. Yeah, again, like still at early stages. Whichever field like you can think of, already computer scientists are working on their problems or software developers. So it's in high demand. We still need more people to learn these skills and get into action and solve more and more problems. We still have like high demand for this job role. Some of the jobs like for example, like oil rig and others, like you can do like freelancing or you cannot be an entrepreneur. If you love that field, you have to be part of a big corporation and you don't have much of a choice. Whereas like this field, you can be a freelancer, you can you can have a startup, or you can work as part of a big corporation on bigger problems. Like it doesn't matter, like you have that choice. And just like I said, like wherever there is high demand, there is always this factor of like getting highly paid, and that's true for software development as well. So the point that I was trying to say all of this is because many times we lose the big picture. We get like too much focused on to one thing, and partly it could be because of our the way that we are raised. Like we are focused on 10th grade, oh, that's the biggest thing in your life. And then 12th grade, oh, that's the biggest thing in your life. And then even now engineering, right? They're going to say the same, parents, teachers, whoever, right? But then in all that, like we miss that big question, like, why? Why are we doing this? Why are we learning this? And if you like, for instance, like if you ask like a kid or any individual, right? Just do something repeatedly like 100 times, they won't be like interested. But if you're saying that, oh, there is a reason for that, there is a goal, there is a purpose for doing that, it's highly likely that they'll actually more inspired to do it. So that's what, like, don't lose the bigger picture. You are solving problems for the world. It doesn't matter whether it's tiny or big, or like, it doesn't matter. Like, as long as you are contributing something to humanity, it's always good. So again, like I can speak with an example, right? So look at this anecdotal evidence. This is my own career. So I was working in studying in Jyoti Engineering College between 2006 and 2010. For this relevant talk like this, I did the two projects. One is my mini project and the other one is the main major for, so S6 and S8, I guess. So the first one was an online shopping portal. At the time, shopping was not a big thing. So I was just exploring how and learning basically how web development works. think I used Apache Struts, a framework that enables like web development at the time with an MVC architecture. Pardon me for all the jargons if you are not familiar with these names. You can always like go and Google it and you'll figure it out how. And I guess like many of the terms that I'm using already have been covered in the past talks. And gait recognition using artificial neural network. So that was like totally different from my mini project. So gait recognition is basically human gait is what like how the way that human walks. So if you are like out in the road on the road, like you're walking, and if you're someone like your friend or relatives are walking in front of you, you don't have to see their face to recognize them. All you have to do is like somehow, or your subconscious will actually figure out that, oh, by the way that they walk, it must be like your acquaintance, right? Or the person that you know. So that's essentially what we were doing with gait recognition using artificial neural network. We used machines to learn someone's like gait patterns and then detect them from a distance. So it had like many benefits over like fingerprinting and other technologies. Again, like learning something. Then I joined Tata Consultancy Service. It was like a 180-degree. So I was like working on this mini project, like kind of like a newer technology. And then I was like thrown back like decades to the COBOL world, IBM mainframes. So they are one of the most successfully running device franchise. Almost all the banks use IBM mainframes. You name it, like HDFC or Citi or SBI or any bank, literally. They are known for their reliability, security, and the funny thing is like companies cannot even own those devices. They have to rent it from IBM. And if you want to like push a code to that machine, you have to get approval from IBM developers. So it's that secure. Anyways, so the code was built on, like coding was mainly on COBOL. I had the honor, I guess, or I was fortunate to basically edit a code that was written way before I was born, in 78 or 80s, I guess. I was working for Amex. Amex was our client. Then briefly, I worked on the artificial intelligence platform with the Java-based platform. And then I moved to university in the United States, Utah State University. So in university, so until so in university, I worked on a totally different field. It was based on biology. So one of the problems in biology is that we want to make these artificial fuel cells, or what is that thing called? Like we want to make products using photosynthesis, for instance, like energy out of photosynthesis, and other there are other synthetic cases where, how to put that? Basically, culture cells outside in a technological world, like artificial meat, for instance. We want to like culture meat cells outside of cow's body, cattle's body, so that we don't have to continue the cruelty of killing poultry or these animals, right? We can like replicate the cells in a lab setting, and we replicate good enough. We can sell that instead of like continuing the cruel tradition of like killing cows and whatnot. So one of the problems for them is actually how to deliver nutrients to these individual cells. So my research was around that. One of the troubles is that biology is like expensive. First of all, it needs expensive lab equipments, and then it takes time to test one iteration by one iteration. So my goal was to like work on a modeling system where we model those cells in a artificial like in an inside computer, and then we run simulations like hundreds and thousands of combinations. And then that can actually help to find the viable candidates, and only those candidates need to be tested in the real biological world. So that paper was published in Frontier. So it's again like in the field of biology, totally unrelated to a typical computer science field. Now, since then, during my internship, I was working in Amazon. I was working on a machine learning or statistical project. Then I returned to Alexa connected devices. I cannot speak too much about what I do there, or what are projects that I work there, because I'm under NDA, non-disclosure agreement. I signed that when I joined that team. So I'm not supposed to like reveal without prior approval. Sorry about that. What I can tell you is that I'm working on the smart home side of it. I'm working on the connected devices, and especially how to connect these devices, different IoT devices, to Alexa. So let's get to the actual topic here, backend development. To understand that, like, we need to know like how this kind of like, the applications evolved. So the initial days, the users were directly interacting with an application typically in a computer or a mobile device, right? And then later there is this issue of like portability. So how can engineers develop a solution and make it available for different type of customers or different type of user interfaces? So for instance, like a global app like Microsoft Word or Google, right? Google is internet. So let's talk about the Microsoft Word. So they need to learn, like, they have like these core concepts that they need to implement, which is like uniform for all the languages. And then they need to, on top of it, they need to like build specific components that tailors to the specific geographical region or a specific locale. That's how we call it in our field. Our local language, right? Spanish, Japanese, or any other language. So we split that into kind of two. The front end is focused on the user or the type of the user. We have different front end components that actually is custom tailored for the type of user that's using it. And then we have the common, we build the common backend to it. Now with internet, it becomes a bit more easier. We can host the backend in internet in the cloud over the internet. And then the front end can be a really lightweight application running on the client side, client's device, whatever that is. So that's kind of called as like software as a service. There are like many benefits to it. Like look at this this slide. Like on the left side, it's a case where we have like more and more like IoT devices, and each need, like, take Facebook for example. It needs to be rendered in a certain way in a cell phone or in a laptop or even like car, right? If it's available, let's say Tesla maybe. But the backend logic, like the recommendation system there, media handling, like the launching videos, storing videos, all that need to be like just built like only for once. So what we did was like we created this backend over the internet, and I mean Facebook did this, and they hired like developers who were like working on or who were like focused on developing mobile apps or laptop apps or computer desktop apps and any other interfaces, right? And then they hired the backend developers who implemented all these complex business logic and hosted that on a website called fb.com. So they have like this certain APIs that actually interface with the internet. All these client applications need to know which API, which URL, basically its address. that we should that those applications should hit for specific use cases. And this load balancer here, the backend API surface, can actually split that into appropriate route that to the appropriate host. It could be the same service, same API, like routing to multiple hosts. I can explain like later, like why that is. So if you look at that problem and compare to a online banking platform, it's you can see the striking like similarities between these two, right? It's over the telephone network. They have a single number to call, just like the single URL on the other side. And once that call is taken, the customer service representative is able to talk through ask a couple of questions and then route to the appropriate folks. And it could be the same thing, like they want to like do online banking, and this customer representative is kind of acting as the load balancer here. Like they're looking at like who is available, and they are routing the request to that particular host. So the benefits of this architecture is that you can add any new interfaces with humans on like without much hassle. And in the backend, you can add as many as new hosts if you want to serve more customers. And this load balancer will actually efficiently scale up for that kind of additional requests. So again, like if you look at this, right, like we are trying kind of like finding similar problems, whether it's in the software development world or outside, right? In this case, it's machines, and the other case, it's just humans. And I can talk about like more deep about these backends, how these load balancing work, and how this routing happens. But I guess like we don't have much time. It might be a separate discussion topic. So benefits: efficiency, scalability, cost saving, fast-paced development, all this. So they are efficient because they are hosted on the cloud. They are serving thousands of customers at the same time. They don't have to run individual code on different platforms. They can coordinate between customer requests. Scalability, they can, like I said, like you can scale these services to any extent you want. It can handle, say, 100 transactions per second all the way to 1 million transactions per second. It's not a big deal. Cost saving. You are essentially like saving the cost of like software updates on every single client device. And you are running all that in a batch in a much more efficient space that is like lower energy and low latency, and which is cheap. Hardware is cheap, literally. So in fast-paced development, you change one code and immediately all your services get that, all your users get that benefit. And of course, like ML and big data, these kind of technologies cannot be like run on individual devices, and it requires big servers. And this kind of architecture helps gathering data or even replacing some of the business logic with these technologies to basically perform better. So we talk about like front end and back end. So this is a cute big photo that I got from internet. So the front end is basically, if you're thinking about that communication language and the interface between humans and machines, the front end is primarily focused on humans or end users. We want to make it as simple as possible, as intuitive as possible to a common man. By looking at those, look at that particular interface, right? The iPhone screen. By looking at each of those icons, the humans should be able to like figure it out without much hassle. And all that big complex stuff that machine can handle like very easy, all that is abstracted away from the user, and it's all in the cloud with running on like much powerful hardware. And like I said, like humans many times they don't even understand how much complex it is. Like whenever we are using WhatsApp or Facebook, we don't understand how many hundreds of employees are actually working to enable that kind of simple intuitive features. It doesn't mean that front end is like easy. I'm scared of front end. uh, it's uh, it's hard. It's hard to like with especially with this IoT world, right? You have more increasing type of interfaces. So with Alexa, we have this voice user interface. With any other devices, usually you have like graphical user interfaces. It could be a watch, it could be a tiny screen on a light or a thermostat. It's hard, and it needs to scale. Like we are increasingly become like globally available, like almost all the technologies, all the companies. So when we release a feature, we want to release it for Canadian, Indian, European, Chinese, like everyone across the world. So and it is hard to maintain that kind of like customization on the front end side, and these guys are like specialized for that kind of skills. So let's get back to the backend side of it. So we kind of do the heavy lifting. So when we are talking about like solving problems, the main part of that business or the problem that we are trying to solve is usually in the backend. So we call it business logic. The exact thing, the code that we write to solve that exact problem, that is called the business logic. Everything else, we call it with the term boilerplate. That is just needed because that's how the framework works. That's how the hardware of the software platform works. But business logic is the key part. And if there were like a utopian world, that's the only thing you should have. We should have like needed to write. Everything else we can like resurrect from the reuse from other cases, or we can auto generate them. Data management. We are dealing with most likely like thousands of users at the same time. We deal with their personal data. Think about like credit cards, email IDs, phone numbers, PAN cards. So we have to like manage that data in a reliable, redundant way, so that it's basically we are not messing it up or we are not losing it. So there are like certain best practices that we build on around that, called data classification. We categorize the data based on the severity of the issue and whatnot. Another angle is the security and privacy. We are increasingly aware of that. We recently had a scandal with the COVID and the Kerala government, some deals. I remember, if you guys are following news, you might have known already. So people are increasingly getting aware of security and privacy. Like many companies, like big companies, might even know us better than the users better than themselves. So it's kind of worrying. Like if getting that data in the bad hands, we are risking changing the landscape, right? The geographical or political landscape, which we saw in many cases in recent history, right? So security and privacy is a big aspect that we focus in our day-to-day lives. Scaling is another one. We want to get to more customers, and we want to like scale our operations across the world. So this is true for almost all the companies. So scaling is one aspect. Internationalization goes along the same lines. Operational excellence. So we designed the problem, we solved it, we deployed it, we made it available to the users. Then what? What if the server stops? What if the number of users who are using this service spiked to a point where the service can't handle it and they started like having issues? So operational excellence is basically on that front. We constantly improve the platform. We constantly fix bugs in them whenever we identify them. We make sure that we don't push like bugs. Bugs is the common term for mistakes in programming that I guess like you already know about that. So that's about the operational excellence. Then development, region versus prod. We cannot mess with our production customers, right? Production customers like live customers, real customers. If you want to say it's a payment ordering service, And if you want to test a new feature with the credit cards, we can't use the customer's credit card to do that. They might lose millions if that feature has a bug in it. So we always have this 2 stages at least. We have multiple stages you will learn eventually. Development versus prod. So we do the changes to the services in development. We test it extensively to make sure there are no mistakes in that code, and then we push that code to the prod. This is called deployment process. In certain companies, they have dedicated teams to do this. Amazon being still following the startup culture, we own it end to end. Who are the typical backend teams clients? So front-end developers, of course, they have a project, they have a use case, they build this flashing UI, and now they want the functionality, so they reach out to us. Product managers, so they own certain features. For example, which one? The Facebook sharing videos feature. So they see that product or that feature shipped, but then they have to work with all these backend teams to get that rolled out, right? Implement all those business logic. So they work with us. The backend developers, clients, product managers are one of them. Other backend teams. So some front-end developer or the product manager or themselves, like they figured out a use case, a problem they want to solve, and they want our help or our system to provide that some features to solve that problem. So they reach out to us. And of course, business intelligence and machine learning teams, they need all this data. So our systems, usually the backend systems, since interact with many hundreds of thousands of users, we have data, and they want to take in that data. They want to draw insights from those big data, and they want to even like create recommendation systems or other things using machine learning on top of it. And there could be cases where we ourselves are using these technologies to host our service. So instead of like having a like that traveling salesman problem, right? Instead of having a code that actually does this, we can actually train a neural network and deploy that instead, which is similar to that bird if we figure out that bird's internal logic. So instance, like things like that we can do. Like it doesn't matter like what kind of technology we are using, as long as the API surface is intact, clients won't have any complaints. So let's look at the typical day. I guess we have 10 minutes left. So let's look at a typical day. People have this misconception of like programming means like or software development means always coding, sitting on a computer laptop and looking at those black and white screens. It's not true. In initial stages, you might do that, but then after a while, you will wish to actually sit on a laptop and code some. For instance, like I haven't coded much in the past few months. I have been working on designs. I have been working on other aspects of that, like what we have listed here. So the very first thing is like gather requirements. Like I said, like we have to talk to others who have problems or that needed to solve using computer science. So we gather requirements and create documentation. I cannot emphasize how important that stage is. Many times people come to us with a requirement and then they change in the middle. So it's easy to lose track of what they actually wanted. So always document them. Then the next step is to formulate that into a technical problem and then solve it using, basically design the solution. So there's 2 aspects of it, high-level design and the low-level design. High-level design usually deals with multiple services or even within one service, like how the dynamics of that business logic should be, how it should be solved. And the low-level design is more into the track where we also look at the limitations of the tools that we are using, say DynamoDB or others, and we kind of like fit our use case, our problems, business use cases into that kind of framework. So that's like in detail design, like much more detailed design. Basically, you read that low-level design, you'll be able to code that into write the code for that. The next phase is the most famous popular phase, implementation and testing. So you write the code finally in the code being language, in the programming language that whatever your team is using. And then you start testing. We don't want any bugs to get into the production and lose millions to the customers or to ourselves. So always do the testing. I have a different slide to explain what testing is and how we are doing it. Deployment. So once we tested the code in the development stage, we push the code to the production for launching the feature to the customers. And it's not a typo there, mentoring. So one of the key aspects is to the software industry change really fast, and a lot more people are onboarding to our teams, and many of team members leave to other teams, and many other team members come join our team. So it's important to basically the seniors in the team or seniors in the profession to mentor or to help out others, look out for them, and help them onboard to our systems, and also make sure that they are learning the best practices or whatever we learned, we are sharing to them. So mentoring is one of the key, and hiring is another one. I didn't put it here. KTLO is keeping the lights on. It's an acronym frequently used in our industry. So basically it means what do we need, even if we are not developing anything in solving new problems or nothing, in order to support what we have, what should we do? For example, Facebook or Amazon, whatever they have, even if they are not creating new features, what should they do? That's basically KTLO. So since we have 6 minutes left, I'm gonna skip some of the slides. So now kind of the industry norm is creating microservices. So just like how we talked about having the flexibility to scale up and whatnot in the internet world, now we are increasingly creating small services in the backend, which interact with each other, which interact with using an API gateway to the external front ends. So that we all these tiny teams who owns these microservices can modify the code at their own pace. For example, in this example, if we want to launch a new feature in this microservice, this web API, we always change that, and we don't have to really test others. We can roll out this change just for that. And that's much easier than having a one single giant service and testing that and making sure that there are no bugs in it. It's it's really hard because hundreds of developers will be committing to that monolithic system, and it's really hard for us to actually make sure that all those code commits are actually not breaking each other's features. Oh, what happened? 1 second. So again, the most popular thing, the coding best practices. There are certain industry norms that we have to follow. It's okay. I mean, we should actually start learning this from the academic setting itself. If you are familiar with programming, look at you might understand. For others, it's okay if you don't understand right now. Eventually, you will get to know. Meaningful variable names. I'll let you read that at your spare time. Basically, what I'm trying to say is we need to code by keeping in mind that it's not just us who's going to read this program in the later stage. Somebody else is going to edit it. Somebody else is going to add more features to it, and they need to understand this code. So that this is not some place where you want to show off your how good you are at Java or any language. This is somewhere something that you should be keep as simple as possible, so that future developers who are working on that piece actually understands how it is and what that means. And there has been there is some saying that code itself is the best documentation that you can ever produce. So yeah, that goes along with these lines. Testing is another major work that we do. So we have three main. There are different type of tests, other type of tests, but these are the main three: unit and functional and integration. So I'll give you a quick analogy. So unit testing is more like checking individual pieces, like how good this tire, if it's a car, like how good those tires are performing and whatnot. The functional test is checking the overall functionality of a specific component or a service. Basically, in this example, like how that drivetrain performs and what are the issues with them and fixing them. And the integration test is like after the full assembly, how does it actually work? How does it interact with different systems? How does the tire actually work on the drivetrain and drivetrain work on that car is a good example. And there's this term called test-driven development. I encourage you to look up in internet. Basically, this is the reverse way of doing it. Like instead of developing and testing, we first write the test to test the logic, and then we make sure that we write the right code for it and the test gets passed. These are the tools, some of the tools that people use, and one of the most common is the Google and Stack Overflow. These are websites where we get all the stuff. We are encouraged to use what others already built. We don't want to like recreate or reinvent the wheel. So we always try to reuse what others have built. And these are the most commonly used tools that that software developer use them in every day. And these are IDEs. So most of the code, like if you are familiar with Java, public static void main, doesn't matter. Like all of that code can be auto-generated. There are like certain tools like annotations where you can like reduce the number of lines that you code, or like optimized in an optimized way, much more human readable way. For example, this is a plugin called Lombok. It's a annotator. Instead of like writing all these mundane methods like getters and setters, you can like just have like 4 variables, just like the left one, and that's it. Like you're done. And many cases, like we can auto generate this code. So once you are like you are in like in the you start your career, you will figure this out. KTLO, keep the lights on. Again, scaling. Make sure that our servers are scaled for our customers, the amount of traffic that we are receiving. Monitoring. We keep constantly monitor all those systems that they are not affecting anyone, like any latencies or any experiences are not failing over. Logging. This is for our own debugging purposes. We want to investigate issues. That's where we go. We check the logs, what happened, what we audit them. Debugging is a similar construct. Bug fix. We of course like always, even after pushing to the code, after extensive testing, we will find bugs, and that's very common than you think. So we fix the bugs and then we make performance improvements. So even if we are not creating new features, these are all the must-haves that we should do. Sir, it's already 11:30, I guess. Should I continue or should I wrap up?
You can wrap up now. We'll have interactive session after that.
Okay. Yeah. Give me 2 minutes. So I want to talk about processes, the normal daily life things, meetings, retrospective, the 5 why analysis. I encourage you to actually look up in internet. This is not only useful in software development, in other fields as well, in our daily lives to some extent. Teamwork, two-way dot decision. I wish I could explain to you. Career growth. You can read this PPT in offline and search in internet. This is all like, you probably know all of this already. Interviews, current state and future. Basically, I want to talk about like so we talked about services and software as a service. Now there is a function as a service and a platform as a service, new technologies. So I encourage you to read about that. This could be the future. Machine learning and AI, you already know that. Common misconceptions: software development is boring. It's a full-time desk job. You always have to code. Programming languages are not for me. I think I already covered many of this, like why it's not true. Summary. So we are engineers who solve problems using computers. Languages are nothing but they're not hard as they seem to be. Yeah, coding is just one responsibility of the developer, and a software developer can work in any of the field of interest. The skill is still in high demand, and you have always the choice. You always have the choice to switch. So that's it. Work hard, have fun, and make history. Thanks.